Okay, welcome back everybody. Got internet back, I don't know what happened. Anyway, trying to keep going. So, a few minutes ago we were trying to determine the pins of the IC which are going to get the power. Those pins will be connected to a few capacitors, and we need to know which capacitor are where and how they are connected to the power, which is the 3 volts. So yeah, I was saying that the pins that we are interested in are the EVDD, which are the analog voltage, and the EVDD, which are the digital voltage. Well, when I speak about analog and digital voltage, it's how they are used inside the IC, but it's the same voltage, and they should be connected to this exact same potential on the board. So I guess they might be just shorted together at some point. So yeah. So the round key here is on the bottom right in the picture. And we are just gonna draw over, so let's say the analog one will be in red. So I guess this one is an analog. No, it's it can't be. This one is an analog voltage. And the one which are connected to the central pad, then those they are ground pins. Okay, so EVDD 46, this is this one. We have DEVDD, which is 39, and we are gonna paint them in green. So I guess 39, yeah, it's this one. Then we have DEVDD, which is 29, which is this one. And then we have DEVDD again, which is 21. So it should be this one, I suppose. If I'm not mistaken. Yeah, we have a capacitor right here. So yeah, and EVDD, which is 15, and this is gonna be in red, and so this is this one. And nothing on that side. So we have 5 pins, and I'm just gonna check on the schematic too that I do have RF here. Yeah, we have 3 digital and 2 analog. Okay. So the green one. Okay, I'm gonna also draw green around those, and red around. Okay, so those are the points where they go down to the 3 volt net. And if we have a look then back to the layer couple files, so we have ground and then those. Okay, and for some reasons, so they have 1, 2, 3, 4, 5, 6, 7 power supply pins. I don't know why actually. It's I don't know what this is. Oh, this is the power supply for the crystal. Okay, which is another, or maybe it's a different voltage. Maybe it's not a 3 volt crystal or something like that. I don't know. Okay, anyway, but they have okay, I'm getting lost. Okay, those two, they have 6. So this one, what is this one? It is connected to this pin through something, and this pin, okay, what is it? So oh, is it the reset pin? Oh, so we have the 12, 13. Okay, yeah. So this is pin 13, which is reset, and which is indeed, there is a pull-up, I guess, on the reset pin. I'm gonna check. I should have reset. Oh, yeah, okay. Maybe they did that with a pull-up. I can check on the schematic too. I think I have it. Do I? Not this file. Okay, this one. And the reset, yeah, it's connected. Oh yeah, okay, they have a button and so on, so okay. We don't really care about that, except if, so maybe we should check to be sure that it has at least an internal pull-up, or if we can leave the reset floating. Oh yeah, we don't really care about that actually. The microcontroller is gonna set that high anyway when it wants to use it, so okay, it's not an issue, we can just leave it like that. Okay, so now we know why they did that like this. And so basically, yeah, so they have one central point and then everything connected to it through separate tracks. I don't know if I'm gonna do it like that. I might try to use a plane for everything. Let's see. I also want to check how they supply the crystal. So it's a TCXO, yeah, I guess. And oh, it's another 3.3 volts supply. Okay, which is VCCB 3V3. And where does that come from? Oh, okay. It's okay, why not? It's just another pin. So you have to supply voltage. Okay, anyway. Hey Wojciech, yeah, so you can't hear me, but yeah, hi anyway. So Andy, the chip is quite easily available, I think, and also quite cheap for what it is. So yeah, let me just check on, let's say, Mouser or DigiKey to see, but I think it's not an issue. let's have a quick look. Yeah, okay, 3000 in stocks in DigiKey and 1500 for Mouser. Not an issue. And yeah, it's quite cheap given what it does. So you can see that it goes from about 390 megahertz up to 510, then 780 to about 1 gig. And then of course you have the 2.4 gigahertz ISM band. And it actually inside the chip there is a baseband modem for several, say, MR FSK, MR OFDM, MR OQPSK, and OQPSK, which we don't use because we have no use of it. But it does have this baseband modem, but it also does have so the I and Q inputs, which we use via the differential pairs, which are here on the scheme, on the diagram for the eval board, and which is, so there's they are here on our schematic, and on the PCB you will spot them easily because it's the track with the wiggles. So with those tracks we send the I and Q baseband directly to the IC, and then it does its magic to put it up to RF. Okay, so now that we know how they proceeded, we know how we can proceed too, and it will be quite easy actually. I might do just like they did, and yeah, maybe I might add an additional decoupling capacitor. Yeah, I think I'm gonna do that. They added a 10 microfarad one, if I remember correctly. Sorry. Yeah, just right here. I don't know why it's faded. It's yeah, usually when the components are faded on the board, that means that you don't fit them or something like that, which I think they definitely did. But I don't have the board to check that. Anyway, yeah. So they added 10 microfarad capacitor. And I think we should do that too, just to be sure. So, okay, let's go to KiCad, open the schematic. We are gonna add it right here. I'm gonna keep an eye on the chat. Okay, right here. Right, so value for the footprint. I'm gonna check what I assigned for the other large value capacitors. Well, large value 10 mic, let's say. It's quite a large value on a PCB for the ceramic capacitor. 0805, okay. So let me just do that to 0805. Okay. Then we can open this, import the changes. All right. Okay. And I'm gonna put it right about here. So yeah, it's 10 mic. It's not. We don't have to place it right next to the input pins. this will be good enough. Okay, so right here we are gonna connect the, so this is a ferrite bead to clean. Okay, yeah, sorry for that again. Let's just hope that this time it's not followed by an internet crash. I have no idea what's happening to the audio. That's just super weird. I really believe that Windows is fucking things up, because it's not the best mic ever, but it's quite a good one, connected via USB. So yeah, maybe the mic is dying, but it's not that old either. So, and I treated it well, so it should be in a good shape still. No, not the AI, please. Oh, why? Oh, I don't like that. Why is this not aligned properly? Like this, it's better. 0.3 millimeters, we want a good connection. So this way it's connected to the plane underneath, goes up here, and maybe we can do let's have a look. Yeah, maybe we can do a small plane on this layer to connect everything. So it's gonna be the EVDT. Why did it change the net? Maybe I don't need that much clearance. Around the thermal relief. Oh, it's making a weird thing. Okay, let's maybe move this up a bit. All right, okay, this is better. And then we can maybe extend it a bit this way. We are gonna add vias to go down to third layer again. And so this is DEVDD. Yeah, let's move that down even a bit more, like so. Okay, maybe let's create corner, create another one. What pitch do I have for the grid? Oh, yeah, it's quite small. Let's use a larger one. Okay, not that small maybe. Why is it? What? How is it? I don't understand how it's moving. Okay, it's... Okay. What are you doing, KiCad? I think it's the 45 degrees thing that we changed in the last stream, I think, to constrain the movements to the position and the planes to have 45 degrees and so on. But it's, yeah, weird. Okay, like this, and good. Okay, I like that. So now we are gonna drop to layer 3, and yeah, maybe we are gonna need to move these down a bit, and we can create a plane. Okay. Maybe I can actually do something else. Can I do that? Oh yeah, nice. It's easier this way. Okay, so now on the layer 3 I have everything I need, and I can just route that to wherever I need the power supply. So I need it here. Can I put a via? Do I have room for that? Yes, I have. Oh, maybe it would be better to do that and add it, add the via right here. And then on layer 3, Okay, back again. I have no idea what's happening. Yeah, okay. I have no idea what I even can do to try to avoid this. So sorry. I just reduced a bit the volume of it, so maybe it will. Maybe, yeah, I don't know, not crash. It's so today the graphic card is working, but not the mic. So it seems that it's either one or the other. Okay, anyway, I was routing the power up to here, and I'm gonna I think I can just do like this and then place via. Right. Okay, let's increase the width. And third layer. Okay, perfect. I think it will be better to do tracks like this. So yeah, we avoid any noise going by the other pins. Sometimes you just have to look at what the manufacturer did and think that maybe they know what they did. Sometimes they don't. Sometimes their design is not that good, but you know. Hey, I just want to place via, please. What? Ah, okay. Like this, it makes more sense. We are gonna have a ground via right here. Okay, third layer, then go straight to here. No, not this one, like here. I like it better here because when we are gonna flood the layer with the ground plane, then we are gonna be able to have ground around the tracks, which is, in my opinion, always better. So we have one more right here. Can we maybe, yeah, I think we can get this closer to the IC. Right, and we can place the via right here, modify it to have the correct net. And then layer 3 and go down, go to the center area. Can I make that fit right in between, or should I go above? I think I'm gonna try to okay, and the last one is right here. For some reason it's the only pad which is fed by a 0.25 millimeter, so let's just do the same for all, yeah, which is 0.15. Okay, so this one is gonna be a bit more, we are gonna do it like this. Maybe move that out a bit, and okay, where can I fit this via? Oh yeah, there is this track below. Maybe that's why it wouldn't place a via. Yeah, exactly. All right, and move this. And so we have plenty of room, right? Right here. I'm just gonna set the width before routing to 0.3 and go here. Okay, so we should be all set with the power supply, actually. Are we? So we just need now to add all the required vias, and I think that we are gonna have some trouble placing them in near some capacitors, because of course we can't place them when we are above some tracks. So that means, so right here should be okay. Hey, why? Okay. So this is good. This easy enough. Yeah, right here. Might want to move that like this so we can put more vias right here. At least two. Yeah, I'm gonna just push that further away because it's just a resistor that we need to set for the crystal input, which is not used, the X crystal 2. And so yeah, it can be further away, it's not an issue. And then we can place more vias right here to grounds. So we have this capacitor and we have those 2 pins too. Oh, I think I might want to edit some pins. Because okay, yeah, this one is not gonna get connected to here, only this one, and that's to mimic what they did right here. So if you have a look, those who are connected to the bottom exposed pad, those are ground pins, but some of them, yeah, okay, so I think it's this one. Is it? I'm gonna try to show you. So this is the pin 1, 2, 3, 4, 5, 6. And we are speaking about pin 20. So 12, 13, 14, 15, 16. So this is our pin 20, and you can see that it's connected to the outside, and the pin 19 is connected to the inside, but not to the outside. Yeah, that's how they did it. I'm gonna do the same. So yeah, we don't need that many vias actually. So we can bring that a bit closer. Like this. Okay. So this also via this is okay, the crystal. Yeah, this I don't need that many, like that. Then also this, but we are gonna do that later. Oh, we also need to route 3.3 volt right here. And we are gonna do that very easily. Let's just route from here. To here, then via it's not okay, why is this plain? No, it's zone name, it's 3v3 in 1, okay. And this needs to be set to the correct net. I don't know why it's not set by default. Like this. Okay, perfect. So this connects. Right, so. And then on the first layer, like that. Do I need 2 vias? I don't know, maybe not. Or maybe I can just do it anyway, it's not a problem. Let's okay, so I can also add this one right here, okay. And maybe I can, okay, perfect. Right, so the TCXO does have its supply now. Yeah, after a few years of using it, you will see that it becomes easier. But I mean, KiCad is, for an open source tool, if you know what I mean, it's surprisingly easy to use, a good interface, and very powerful. There is only a few features that it, in my opinion, it does lack, but that's not a killer. And yeah, really, it's very good for an open source tool. I think we all have in mind at least 1 or 2 open source tools which are either a mess to install or a mess to use or understand, with a very lacking documentation and so on, or low support, I don't know. The documentation of KiCad is maybe not always the most up-to-date, but you have a very large online community which can help you when you have troubles. So it's very good. Also, of course, free, which is always a pleasure. Free as in beer, but also free as in speech. So what more to ask? Okay, so we have our ground vias for these capacitors. This is all RF tracks, so we are gonna do that later on. We have to be careful with those. These pins, how are they connected? Sorry, got catched on a Discord mention. So the ground pins, how did they connect them? So it's the pins which are right, okay. So the ground pins here, so all the pins which are connected to the exposed pad are also connected to the proper ground, let's say outside grounds. So we need vias also about here. Let's insert them, and we are gonna do the rest along the RF tracks later on. Yeah, we need some clearance around those pins. I wish I might move this group a bit to the right so that we have more room right here, because those two are being routed out and then to a header, so that later on during the development process, if you want to try playing with external amplifiers and so on, we can. But I also need to place a ground via, so I will need to make some room for that. Maybe can I? Okay. So let's try. Okay, like this. Can I drag? No, there is no drag feature. Okay. Okay, like this. So this is considered as a differential pair. Just remove those. Okay. Okay. And so now I have room for a few more vias right here. Yeah, it should be. It's not that critical. If it's just a few fraction of a millimeter longer. We need to route that out, which can be done like this. Okay, we'll do that later on. Here, decoupling and a ground here, so let's add via here, here, and here. Okay, do we have? I guess we won't be able to fit a ground via here, will we? Oh, we can. Barely, but we can. That's just what we need. Okay, amazing. This actually, let's allow removing redundant tracks. Go to third layer and route like this, so that we can have ground vias right here. Okay, this is the one which is gonna be annoying. We might have to move things around to clear space to be able to fit vias right about here. How would we do that? So we have the three light blue which are on the bottom layer, which are SPI signals. Yes, Andrzej, sorry if I don't pronounce your name correctly. Yes, exactly. So as a reminder, the ground, the green plane that you see right here, it's what I like to call the true ground. It's one continuous plane which is used solely for ground, only grounds. This allows us to have a very stable reference, homogeneous on the board, and also it kinds of play a role of shield. There are also return currents which usually flow below the tracks which bring the signal from point A to point B, let's say. From point B to point A, you will have a return current, usually flowing through ground. And for that, you need a very good homogeneous ground layer below those signals. So that's what the green layer is for, and this is connected to ground on the power supply and ICs and all the parts that need ground, basically. And so, yeah, when we are on the top layer, the red one, and we want ground, we place a via, which via basically it's you pierce the boards with a small drill bit, basically, and then you deposit metal on the edge of this hole, basically. So yeah, this is metallized hole, as we call it, and then it's gonna do a connection between all the layers, basically. So if you have a look maybe on this, it's gonna be clearer. So let's find an example. What via could I choose that is easily to keep track of? Yeah, this one. You see this large via? So it's on first layer, you have a track going out of it, and then through this, which is a capacitor, and then connected to the IC. Second layer, it's the ground, and you see that there is clearance around the hole, because the plane is ground and the hole is power. Then on the third layer, you have a track connected to the hole and going to the common power supply point. And then again, on the fourth layer, you only have a few signals and then ground. And so again, there is clearance around the hole, which is, yeah, a via, as we call it. So basically, then it's gonna make a connection through the board vertically from this track to this one. And then again, this hole is connected to this capacitor, and then this, which is an input header for the power supply. Okay. So yeah, connecting, placing ground vias. I will try maybe to move those like this. And then I can move that like this, and this. Yeah, no, I don't especially need to move that one because it's already below the pad, so it's enough. And then I would need to move that. Okay, let's try to maybe I can divert that a bit like this, so that I have space to move this via around here. I have room right here and right there for those two vias, and I can move this capacitor up a bit. Okay, right, so oh yeah, I can do that too, like this. and then also do that. Actually, I can even do this like that. And this will need to move up a bit. And now we should have plenty of space for 2 vias. I think we should be able to fit 2 at least. This can go down a bit and even move this way. It's a bit, so we can put one here. Yeah, perfect. We have our 2 vias. Amazing. Okay, this is, I don't like that. Maybe I can. Yeah, okay, great, perfect. Okay, so I think that's pretty much it for the power supply, actually. Okay, is this, what? Oh. Okay, this is weird. I think I can hear you properly. I'm just gonna try to set some kind of Okay. Yeah. I don't think it's KiCad which is the problem, but my culprits, for those of you who speak French, well, you don't really need to understand French to read Windows. And you can also see that it's kicked up. It kicked on basically just before I started Audacity, which used the mic. So basically, for some reasons, Windows decided that my mic settings are not correct. I don't know, and then just fucked it up. You think it's OBS? Well, just right before I started KiCad to record myself, it's Windows who kicked on, and maybe I can also have a look to see if it might be. I don't see anything that OBS could be doing to this, to the mic. Yeah, I really don't see. I might have a look at the sound driver or something like that. I haven't installed any on this computer. I will try to do that for the next stream, maybe. See if it fixes things. Oh. No, could it be there is a secret? Yeah, yeah, you make a good point. That could be. Let's see. But the thing is that in Windows I don't see any shortcuts, any gain settings for the mic. So yeah, for maybe if this would be an analog mic. It's not connected, so I can't really change things, I guess. But I don't see any gain settings anywhere. It's Windows 11, but yeah, control and mouse roller. I don't know. Let's. It doesn't seem to be changing anything. No, okay. I'm looking at OBS at the same time, and I see that the volume is going down. I'm trying with Alt and mouse and click and merge and control and so on, but doesn't seem to be reliably doing something. Yeah, let's use YouTube to see if there is any. Oh, maybe. Yeah, there is still this old thing in Windows 11, it seems. Yeah, but it's redirecting me to the same panel that I already use. I also, yeah, in the meantime, I changed this to back to CD quality and not DVD quality. I don't know if it can change something or not. Yeah, okay, this video is useless. I'm not using a USB hub. It's cable straight to the. Yeah, change straight. USB straight to the computer. And hello, Steve. Yes, we changed the settings to French troubleshooting language because the mic has been acting up again, and for some reason, from time to time, before that it was going down so that you could not hear me, but now it's going up so that you can hear me, but you cannot understand me. And yeah, I have no idea what is happening because I don't see any gain settings in Windows. OBS doesn't change the volume of the mic by itself, and even then things are best troubleshooting language is French. I don't agree. Whenever I'm doing technical research for troubleshooting or something like that, always in English. Anyway, oh, if you want to know a few words in French, it can be easy. You can just say bonjour, which just means hello. But then you can also use lots of curse words if you want to. If you want people to think that you are really French, then you should use them a lot. Amour, yeah, it's a nice one. I prefer strapontin, which is also very funny, but nothing like amour. All right. What do we have to? Oh, we have forgotten the via right. The via is right here. Let's use 3 for that one. Pain au chocolat ou chocolatine? Yeah, that's quite a fight that you have in France about that. In Belgium, we use pain au chocolat, so it's alright. Sometimes I like to trigger my friends who eat croissant au chocolat because it's something else, but even it's a new chocolate pastry, so yeah, it's funny too. How are those two connected? 23 and 24, let's check. Oh, they are, okay, they should be connected to the outside ground plane. Maybe I can, if I do this, then I'm gonna have enough room. Okay, like that, and this is good. Yeah, okay. Maybe I can even short them like this. Okay. Oh yeah, so we have also the battery voltage going down to there for the power button controller. And yeah, we talked about moving it. Yeah, but I think it's good like this. Maybe we can just drag drag a track down to there. Oh wow! YouTube just invented negative viewers. I now have -1 viewer. That's nice, I guess. Let's screenshot that. Yeah, it's thanks for your interest, guys. It's very nice. Oh, you're the -1. Get out. Oh, we didn't place any ground vias here. I don't know who is the negative viewer, but please go away from my stream. Okay. Oh, how can I? I will swap that to be like this. Actually, this needs to move, but it can be connected. This can be connected like this. French Canadian guy. I love the accent from Canada. It's Quebec. Yeah, funny accent. Lovely though. Why does it keeps doing this weird thing of putting tracks in a weird angle? I don't know. Okay, so yeah, it's much better this way. So we have a way to connect to ground here. However, I don't like the fact that yeah, it's gonna cut through the plane, so I'm gonna do it like this. Okay. Yes, of course, the accent is relative to where you live. Yeah, okay. But do you find our accent funny? That would be interesting. yeah, YouTube algorithm be like, is negative in absolute value? I mean, negative is interesting, but no, we are back to 1 viewer, and no, we are back to 0 concurrent viewers. I really think that it's not accurate. Why do we have like 0 concurrent viewers, but people answering to me in the chat for some reasons? YouTube, yeah. I think it lives in its own reality. You are a ghost. Oh, thanks, Steve. That's nice. Anyway, I think I'm soon gonna stop this stream. I need to go to sleep eventually. Okay, this one is connected like this. It's okay. Vias right here, missing vias. No, I didn't place any right here. Oh, surprising. Okay, yeah, sorry for the sound. I hope I can get this fixed for the next stream. But yeah, no, I don't promise. I'll see what I can do. I just saw missing vias right here. Let's add 1 and 1. I'm not sure about the shortcuts, but I mean, if it's a shortcut, if it is a shortcut to a function that I don't see in Windows, because yeah, there is no gain settings anywhere, and I just have to disable and re-enable the device for it to work correctly. So it is Windows related for sure. Maybe I can go to the settings again and no, those are yeah, I don't see where it could be. Anyway, I'm gonna try to install the drivers for that and see if I can have any settings change or something like that. Anyway, that's gonna be for the next stream. I think I'm pretty much done with all the power plane routing. Oh no, I wanted, yeah, let's try to do the battery, and then it should be good. The battery to the push button monitoring. So I just need to decide where I'm gonna, how I'm gonna route that. Oh, actually, I can drag a line, and this only needs like a few microamps, so I can just use any thin tracks, no issue. However, when I think about it, what could be is that whenever I click, the mic picks up the noise, and then Windows tries to compensate for this noise that shouldn't be, like, it's maybe fucking up an algorithm in Windows which tells the system to increase the volume or something like that, and then it tries to fix what is not an issue. Yeah, Pierre, I really don't think it's related. It would be very weird. Anyway, I said that I was gonna route the battery down to the battery monitoring IC, and I did it. So yeah. Yeah, maybe I could use audio monitoring. Yes, indeed, you're right. Let's discuss that aside and see what we can come up with. That could be nice. Yeah, I'm gonna give up for tonight too, and terminate the stream. Okay, so what is left for us is battery, then the fuse. We also need voltage divider bridge to be able to monitor the battery voltage from the MCU. And then a few IOs that needs to be routed to and yeah, that's pretty much it, I think. Okay, well, anyway, just before the mic screws up my voice again, thank you all for following along tonight with all the internet and mic issues and so on. It have been fun, hey, or not, I don't know. I'm gonna push the changes to the Git repository. So yeah, what did we do? Yeah, we added capacitor. Okay, and push. Okay, thank you everyone. 73s to all of you, and see you on the next stream with hopefully better audio. Bye bye.